Welcome to the AI Research Roundup. I am Alex. Today is June 9th, 2025. We're looking at a paper from Hugging Face's trending list, published just about 2 weeks ago on May 27th, titled, Will It Still Be True Tomorrow? Multilingual Evergreen Question Classification to Improve Trustworthy QA. This research tackles how large language models often struggle with questions whose answers change over time, what they call mutable questions, versus those with stable answers, or evergreen questions. It introduces a new dataset, EverGreenQA, and a classifier to help tell them apart, aiming for more trustworthy question answering. Alright, so this first figure clearly illustrates the core idea. It contrasts these two types of questions we've been talking about. You see a green dashed line for an evergreen question, like what is water's freezing point? Its answer remains constant. Then, there's a red fluctuating line representing a mutable question, such as the average global temperature rise since 1850. Its answer obviously changes over time, and the graph even shows a projection period. This visual really highlights the challenge LLMs face with time-sensitive information. Building on that understanding, this table then compares their new EverGreenQA dataset to other existing time-sensitive datasets. You can see EverGreenQA is the only one, checking all the boxes. It includes both evergreen and mutable questions, has a proper trained test split, is human evaluated, and importantly, supports multiple languages. While some other datasets are larger, none offer this comprehensive set of features, underscoring its unique contribution to studying question temporality. This really sets the stage for their classifier. Okay, so now let's look at this table. It directly compares how well different models, including many well-known LLMs and their own EGE5 classifier, can identify these evergreen questions. The numbers you see are weighted F1 scores. An F1 score is a measure of a test's accuracy. It considers both how many of its positive predictions were correct and how many of the actual positives it managed to find. Across all 7 languages and on average, their EGE5 model, with scores highlighted in bold, clearly outperforms all other benchmarked LLMs and prior methods. This really shows their specialized classifier is a big step up. So, while their EGE5 classifier is great at explicit identification, this next table explores something else. It examines the implicit awareness of LLMs regarding question temporality. What you see here are correlations between known evergreen questions and 2 common uncertainty signals from the models. Perplexity, which reflects how surprised a model is by a sequence, and mean token entropy, measuring average uncertainty per token. These correlation values are generally quite low, typically below 0.35, indicating LLMs don't inherently encode much temporal information this way. This finding really underscores the value of their specialized classifier. Okay, so moving on from how LLMs implicitly encode temporality, this table now shifts to a very practical application, improving an LLM's self-knowledge. Basically, how well it knows if it knows the answer. We see results across several datasets using metrics like OROC, OPRC, and PRR. OROC, or Area Under the Receiver Operating Characteristic Curve, and OUPRC, or Area Under the Precision Recall Curve, are common metrics. They help us understand how well a model can distinguish between different outcomes. PRR, or Precision at Recall Rate, also assesses this. The key here is that when the model's evergreen probability, that's the EG in a table, is combined with other uncertainty signals, or even used alone, it often leads to better scores, shown in bold. This really shows that their classifier helps LLMs better judge their own knowledge. Building on how the classifier improves self-knowledge, this table explores another application, filtering QA datasets. We see performance on various datasets, comparing evergreen and mutable questions. The columns show results for zero-shot, which means answering without extra context, and retrieval augmented generation, or RAG, a technique that provides the model with relevant documents to help answer. For instance, the MUT% column shows that the NQ dataset contains 18% mutable questions. And importantly, the MUT-RAG gain % shows retrieval augmented generation really helps more for these time-sensitive mutable questions. This suggests understanding question temporality is crucial for fairer dataset evaluation. So, to wrap things up, this research really underscores how crucial question temporality is for trustworthy question answering. That's whether a question is evergreen, with a stable answer, or mutable, with an answer that changes. The authors introduced the EverGreenQA dataset and the highly effective EGE5 classifier. This classifier significantly improves LLM self-knowledge and helps create fairer benchmarks. It even provides insights into why models like GPT-4o retrieve information. Thanks for tuning in to the AI Research Roundup. I am Alex.